This is part 4 of section 4.4. We've talked about having a multiplier in front of our trig functions. Now we're going to talk about where we have a multiplier inside the function, inside of the argument of the sine function or the cosine function. If in section 1.5, we learned that a multiplier inside of a function changes it horizontally. It will compress it in or it will stretch it out some. So when it comes to a trig function, what this does is it changes the period. It's going to stretch things out possibly so that we have to go further to get one cycle of the graph, or it might compress it so that we don't have to go as far. Okay? So if we look at just a comparison of some of these values, here we have just the blue line here is sine. Okay, and its cycle is completed in 2 pi. If I have sine of 3x, that thing compressed it down so that now it is completed in a shorter cycle, and it completes its whole cycle in 2 pi over 3. Here, if I have a multiplier of 1/3, it now takes 6 pi to create, its period is now 6 pi. It takes 6 pi units to complete one cycle. Okay? Now what this ends up being is you take the cycle, the period of regular sine of x, and you end up dividing it by this value right here. Okay? And that's true for both sine and for cosine. So here, in general, we sort of combine these things together. If I have a function that looks like a times sine bx, or y equal to a times cosine of bx, and I'm only worried about my b values being positive. If they're multiplied by a negative, then we use the even and odd properties to simplify that. We can always make that multiplier a positive number, okay? We know that the amplitude is going to be the absolute value of this multiplier in front. And the period of that function is going to be 2 pi divided by b. Okay? And it's 2 pi because sine and cosine both have a period of 2 pi. And then if the argument has a multiplier, it ends up breaking it, changing the period. Okay, so the range of something like this goes from negative a to a. We've talked about that already. One cycle is completed over the length of a period. We know that the period is 2 pi over b, so the cycle is completed over 0 to 2 pi over b, whatever that happens to be. Okay? Now the x-coordinates for the 5 key points, and this is true for all of these, it is 0, it's the beginning one, and 2 pi over b will be the end one, of course, because that's how long it takes to do a cycle. And basically everything in here is just broken up into fourths. So you just need to find 1/4 of the distance between here and here to break it down. So whatever this is, if you divide it by 4, you get pi over 2b. This divided by 4, you get that. Now add another 1/4 of the way here, another 1/4 of the way here, and then you're here. So these are your x-coordinates. And we know for our 5 major points on both sine and cosine, we will get the amplitude either positive or negative or 0. So right here for a sine of bx, it starts at 0 and it goes up to your a value, down to negative a, to here. Cosine has this basic shape as well. And you're going to start on the x-axis for sine, start on the end at the x-axis here. Start at your highest point for cosine, end at your highest point for cosine. And then if your a value is negative, then we flip it over the x-axis. Okay? So let's just sketch the graph over a 1 period interval for sine of 4x. Okay? So we had y is equal to a sine of bx. So comparing here, our a value is 1, our b value is 4. My a value is 1, so my amplitude is 1. So I'll be going up to 1, down to -1. Now, b equal to 4, this changes the period. The period is always 2 pi over b. So this is pi over 2. So we will complete one full cycle. One cycle is going to be from 0 to pi over 2. Okay? Now, the x-coordinates, okay? Your first one is going to be 0. Your last one is going to be pi over 2. Okay? If we find the distance of this and then break it into 4 pieces, so the distance between 0 and pi over 2 is pi over 2. If you divide that into 4, that's pi over 8. So we're going to go up pi over 8 each time. Okay, so if we're starting at 0 and we go up pi over 8, then our next x-coordinate is pi over 8. Add pi over 8 to this, and you are at pi over 4. And then 3 pi over 8, and then pi over 2. Okay? Now, when we are dealing with just regular sine, our first major point, 0, that goes to 0. And then we go up and then 0, down, 0. This will go up to 1 times your amplitude. So this goes up to 1. Then this goes to 0. And then you've established the pattern. This will go to -1. And this one will also go to 0. Okay. Now, I would multiply these y values by the amplitude if I needed to, but over one cycle I have 0, 0, pi over 8, 1, pi over 4, 0, 3 pi over 8, -1, pi over 2, 0. And now connect these smooth with a smooth curve. And that will be this answer graphed over a 1 period interval. Okay. Now let's do y equal to 3 times cosine of 1/2 x. In this case, our a value is 3. So that means our amplitude is equal to 3. So that means on our 5 major points, wherever I have a 1, I'll be putting a 3. Wherever I have a -1, I'll be putting -3. Now let's find the period. The period is 2 pi over b, which is, since my b value is a fraction, you may want to write it like this. So this is 2 pi times 2. So our period here is 4 pi. Okay? Now, so that means we're going to break the whole thing up. The whole cosine function is going to happen between 0 and 4 pi. Our x coordinates that we're interested in, we start at 1 cycle is going to be from 0 to 4 pi. Our 5 major points, our first x value is 0. We would divide the length of this period by 4, so that's pi, so we're going to add pi every time. So our next x value will be pi. Our next one will be 2 pi, then 3 pi, and then 4 pi. Okay, so these are the x coordinates of our 5 major points. If we're just listing our 5 major points for cosine first, just regular cosine, 0 would go to 1, pi goes to 0, 2 pi goes to -1, this one will go to 0, and then this one will go back to 1. So +1, 0, -1, 0, 1. The same thing happens here. You just got to remember what number you start on. Okay? Now up here, I was able to just plot these points because my amplitude was 1. But here, my amplitude is 3, so I need to plot these y values multiplied by 3. So I'm going to plot the points 0, 3, pi, 0, 2 pi, -3, 3 pi, 0, and then 4 pi, 3. 0, 3 is here. Pi 0, go down to -3, back up to 0, to +3. And then connect these with a smooth curve. To get your graph.